Hello guys, we are here back with another special video of the solution to the problem of the day on Leetcode, which is finding the minimum number of taps to be opened to water the whole garden. Okay, so this is a hard problem. Although it is termed as a hard problem, if you understand how it is done, then similar problems can become medium or maybe easy for you. So let's make the hard one an easy one very quickly. So basically we have been given a garden, let's say, which has taps at point 0, 1, 2, 3, 4, 5. You can see that in this figure also. So you have to water all of the grass patches or the areas of garden which lie between the taps, which is between 0 and 1, between 1 and 2, and all of them. And you have also been given the ranges a particular tap can supply water to. So these kind of arrays will be given to you so as to let you know that what is the range of each and every tap. So you have to decide which minimum number of taps will have to be opened so that we can water the whole garden. So in this 5 patches are there and we have to water all of them. So how we will do this? Now a very brute force solution can come to your mind that I can apply each and every permutation combination of taps and check whether this combination of opening of taps is supplying water to each and every patch of garden or not. If it is supplying, then I will check whether it is the minimum one, and after this whole process of maybe 2 raised to power n operations, I will get to know my answer, the minimum number of taps. But as you can see, it will be a very bad solution, not in far from efficient solution. So what can we do? Let's try to think. If we just start iterating from the 0th tap, if we see that, or that if I want to water this first patch which lies between the tap number 0 and 1, then there are 2 taps supplying water to this position. So if I think greedily, then it will be better for me to choose the tap which has a higher range, because if I choose a higher range tap, then I will not need a smaller range tap when I will look for watering the other patches of the garden. So yes, I can do that. Let's see what happens if I use that algorithm. So I check the biggest range tap for patch 0 to 1. Okay, I take it. Then for 1 to 2, if it is already covered by any of the tab that we have already chosen, then we can move ahead. So in this particular test case, the biggest tab that we have chosen in the first case only, in the first patch only, is supplying water to all of the patches. So every patch will get covered and no tap other than the first one will be needed to water all of the garden. But what if it would have been a smaller tap and I would have got a big tap later? So in that case, I would need to remove the tap that I had already taken earlier, because the new tap that I have encountered in the array is already covering that position. So we have to store the taps that we are using, and if another tap comes having a bigger range, which basically removes the need of using the few tabs which we have already included in our list of tabs, then I would need to remove that. So what can we think about this? What do we remember? Which data structure can do this thing? Which data structure can efficiently perform this task of letting us remove previous elements and add new elements on the top? Yes, you guessed it perfectly right, that it's a stack. So the algorithm that I will be using is displayed to you in this picture. So as you can see in the left image, that first we put tap at index 1, then we put tap at index 4, and now we are aiming to put tap at index 5 by replacing tap at index 4, because putting that will benefit us and will reduce the number of tabs. So I hope by now you might have understood the algorithm that we are going to use to solve this hard problem, which is marked as hard, but we will make it easy. So this is the code of using the stack that we will be using in this problem. So as I have told you that we are using a stack and we are putting the number or the index of the tab that we are using and the lower limit of the range of tab that the specific tab is supplying water to, means the last position at which the current tab is supplying water to. Okay, so I will also keep this variable cover to ensure that I have covered all of the patches, and at the end if the cover is less than equal, if it is less than the last patch, I will return -1 because I will say that it is not possible for me to cover all of the patches by using all of the tabs or any combination of tabs, and the stack at the end will store all of the tabs that I have used. And if the size of the stack is 0, then also I will return -1, otherwise I will return the size of the stack. Now I am running this for loop for all of the patches, or you can say all of the tabs, because there are n plus 1 tabs, so I will run my loop from 0 to less than n plus 1. So let's say we have come to a specific tab, and if the range of the specific tab is 0, I will skip that tab, because range 0 means that it is not even able to cover its any patch or its nearby patches, so it is of no use for us. I will then run a loop. Now I will just pop out all of the unnecessary tabs. If at the end the tab that I am currently standing on, if it is necessary, then I will push it into the stack, otherwise I will move on to see what other tabs have got to offer. Now here I initialize the current values. If I am standing at the tab I will say the current lowest patch that the current tab is able to supply water to, and the highest patch index which our current tab is able to supply water to, and these are just values which are self-explanatory, and so this was the current values. If the stack is empty, so if there has been no tab till now, then I will just push the tab that I am currently standing on. So I will say the tab at ith index will be pushed, and the current low, which will of course be equal to 0 because it's the first tab, so it will supply water from 0th patch to whatever the highest patch it could have supplied according to its range. And if current low is 0 is or greater than 0, which means it is not even able to supply the first patch, so it is of no use. We will go to look for next steps. So this is what this if block is doing. Then I will, now the stack is not empty, so I will retrieve the top value, which will be the topmost tab which I have recently added to the stack. Now I will check whether this tab is necessary to be used. So I will check the lowest value this tab is supplying water to, the highest value the tab is supplying water to. If the highest patch that the tap is supplying water to is greater than n-1, it means that it is supplying water to all of the patches, so it is of no need to look for the taps, and I will return s dot size, which means the current taps are sufficient for me to water all of the patches, so it is of no need. So I think that you might have now got the meaning of these four variables: current low, current high, top low and top high, which we will be using in the cases that we are forming in the code head. So I will say, if let's say in this condition what we are doing is current low is greater than top low and current high is less than equal to top high, which means the current tab is supplying water to only those patches which have already been covered by the previous tab. Then current tab is of our no use. I will just break the loop and I will not push this tab into my stack because it is of our no use. Else, let's first analyze this condition. Else if current low is less than equal to top low and current high is greater than top high, which means my current tap is supplying water to all of those patches which were being supplied by the top one, as well as some more patches also. So this one is better, so I will just pop the top tap out, and after popping it out I will again come to the loop, and then over here it will go, and here I will push the current tap into that, so that loop will all automatically take care of itself. And if there is any other case, I will break the loop. Now let's understand this one. If current low is greater than top low, which means the leftmost patch that our current tap is supplying water to is after the leftmost patch that previous tap was able to supply water to. So it's fine. If current low is greater than top high plus 1, it means that our current tap is this much far from the range of the previous tap that it is skipping one or two patches. So this tap is of our no use, because it is not even covering the intermediate patches that come between a current tap and previous tap, so it is of our no use. And if it is just one step ahead of the top high plus 1, then I will say that we can safely push it into our stack and move on. Otherwise, if it is less than that, so accordingly I will update the stack values. I will push my current tap into the stack and update the lowest patch that this tap will be supplying water to, and this variable is just to store the highest patch that I have till now supplied water to. If this highest patch becomes equal to the last patch, then I am good to go, and my answer is absolutely perfect. So this is how this very simple algorithm of ours is working. So if you have understood the problem, then it's great. If you have been not able to understand this problem, you have some doubts related to it, then also it is great, because you will give us a chance to answer your queries and grow together. So for more such videos, please subscribe the channel as well as like the video. And of course, as I have already told you, that asking doubts to us is very easy, and I will answer your queries as soon as I see your comment. So thank you very much for watching the video till this end. It has been a great motivation for me. So keep coming to such videos, and thank you very much.